Okay, let's get started. Okay, now, everything I give you, every fact I give you is going to be very important for this topic. I'm not going to waste any time in speaking. Yes? Okay, now, because we have so little time before the final exam, the semester exam, I'm not going to give the stoichiometry test before the exam. It'll be after the exam. Okay? I might even give it during the exam period. I don't know what I'll do, but it's not going to be on the exam. It will be on the exam, but I'm not going to test you officially on stoichiometry until after the exam. Clear? But I'm going to give you eventually a paper on that. Okay? Yes? Okay, now, this is the deal. You have the mole. Correct? That's the topic. That's the main topic in stoichiometry. Now, a mole is simply a number of things. Jung-in, do you know what a dozen is? That's like an English thing. Do you know what a dozen means? What does a dozen mean?
Measure.
Well, what does it mean? Well, tell me what a dozen eggs, how many are in a dozen? 12. That's right. So 1 dozen. 1 dozen is 12. A mole is the same thing. It's a count. This is a count. A mole is the same thing. 1 mole. Right? 1 mole is a number. Does anybody know what that number is? Yes?
Isn't it 3 something times 10 to the power 6?
No, a lot more than that, girl. Chile.
Avogadro's constant?
Avogadro's constant, yes. Avogadro didn't come up with it. It was named for him. But what is the actual number? If a dozen is 12, what's a mole? Lauren?
6.02 to the power times 10 to the power of 23.
That's correct. 6.02 times 10 to the 23rd, 23, right?
Yeah.
That's what you said, right?
Yeah.
Okay. So that's what it is. I don't think you can appreciate the word mole by looking at this expression in scientific notation, 6.02 times 10 to the 23rd. Do you think? It's actually 602. Is that right? $16, $17, $18, $19, $20, $21, $22, $23. Big number, huh? All right, so that's a million. That's a billion. That's a trillion. American thing, trillion, right? Don't they say 1,000 billion for a trillion or something like that in Britain, UK? So, right? Big number. We'll leave it at that. Big number. Okay. So, it's a big number. Yes? You get it? That's the chapter. No, not really, but there's a few things that are really cool about it. This next sentence is so important. This is probably, if you want to isolate a single sentence in topic 1 that has the most meaning per sentence, this is the sentence. Stamp this on your forehead. Hang around with people in this class so you can read the other person's forehead so you know what's on your forehead. Look in the mirror a lot and be able to read mirror backwards. Make sure you know the sentence. Make this a part of your name. So that's going to be your new middle name is the sentence. Okay? You ready? Does this all come on the thing? Make sure it does. Lauren, you're the videographer here.
Yeah.
You're my producer.
It's all working.
The mass in grams of 1 mole of any particle That's ion, atom, molecule, formula unit, is equivalent to the mass of one particle in AMU. Okay? Let me get another marker here. That's so important, guys. This is it. You know what I'll do as well? No, I can't, I can't mess around with this. I can't, waste time on this at all. I want to give you quizzes, and this takes me like a month to teach normally, but I've got to, reduce it down because no, you can't map any more hours. No, X number of hours, that's it. Okay? So that's it. And what does that mean to you? What does that mean equivalent in atomic mass units? Well, I know that sodium is 23. That's sodium. Start writing it like that, by the way. Make sure you do. And I think we've done that, haven't we? Yes, when we did atomic theory. On the left side, you have a superscript is the mass number. Subscript is the atomic number. Mass number, atomic number. Well, I know that the mass number of sodium is 23 AMU, right? If I took this many sodium atoms, what would be the mass in grams?
1 mole.
What would be the mass of 1 mole in grams? No, you said 1 mole is the mass?
Yeah.
That's like saying, what's the mass of a dozen eggs? 12. No. Does that make any sense? Because dozens count. It's not a mass. So by saying, what's the mass of 1 mole of sodium atoms, and you say 1 mole, doesn't make any sense, does it? No, and it's good that it doesn't make any sense. Because if it made sense to you, then we'd be in deep doo-doo. Deep doo-doo, okay? It doesn't make any sense. Okay. So what's the mass in grams of a whole mole of sodium atoms? What does the word equivalent mean?
Equal?
No, not really equal. Equivalent. Basically, the number is the same, but the units are not. Okay?
So
Yes.
AMU, it's grams.
Yes! Excellent! You got it, girl! Got it! The mass in grams of 1 mole of any particle, atoms, ions, molecules, formula units, is equivalent to the mass of 1 particle in atomic mass units. So if the atomic mass is 23 atomic AMU, then, or you could say 23 U, that's used as a short for AMU, U, okay? Then it's going to be 23 grams. So it says, measure out 1 mole of sodium, be 23 grams. What's 1 mole of water? What's 1 mole of water? I'm going to give you a hard one, based on what you should have learned before you came in here. This you learned. Between what we did today and what you did last year, the year before, or the year before that in middle school, you should know this. And that is, what's the volume of 1 mole of water? 18 grams is the mass, that's right. What's the volume? 18 milliliters, because the density of water is 1, right? Right? Because it's going to be 18 grams over 18 milliliters equals 1 gram per milliliter. milliliter being the same as cubic centimeter, right? So it's 1. So it's 18 grams, 18 milliliters, right? Right? So I can hold 18 milliliters in my palm. Maybe not your palm, but my palm just. Maybe a little over if I don't shake. Yes? You get that? Isn't that easy? Yes or no? So now you got that, right? I'm going to leave that sentence up there, and I'm going to do a balanced chemical reaction. You're going to know a good 30% of this chapter before you leave here today. Okay? Jung-in, that's a little scary, isn't it? A little scary? Okay. So, you know, from middle school, because I've got to somehow hook on to what it is that you actually learned there. I'm not saying you didn't learn something, but... Okay. I like the deadpan, that's really good. Okay, it was actually pretty funny. So 2 hydrogen plus O2 yields water, plus a whole heck of a lot of energy. Do you understand that that's true? Do you understand that that's true? Yes? It's balanced. Let's not balance it. Balancing equations actually, I don't teach balancing equations. At your age, just do it. It's not hard, guys. You know, the way they teach balancing equations, it's what we call in New Jersey rabbit hunting. How do you catch a rabbit?
You run after it?
You run after it and you put salt on its tail.
Because the rabbit stops to lick off the salt?
No, if you put salt on the rabbit's tail and then you grab it, right? It's called rabbit hunting. What's the moral of the story?
Send dogs after it instead?
No, if you're close enough to put salt on its tail, just leave the salt at home and grab the rabbit. So don't make a big deal out of this, okay? Look, you have 2 hydrogens here, you have 2 there, balanced. You have 2 oxygens there, you only have 1 there. It needs to be balanced, so what am I going to put in front? You can't mess with the subscripts.
You put 2.
That's the big thing they teach you. You only use coefficients. You know what a coefficient is? You guys have had enough math to know what a coefficient is? Thank God. So you put a 2 there. Well, that screws up the hydrogen. But the hydrogen's alone. You have 4 hydrogen there, so you put a 2 there. Are you done now?
Yeah.
Yes or no? Do you see that this reacts as 2 particles? H2 is 2 particles. 2 particles of H2, right? Plus 1 particle of oxygen yields 2 particles of water. Do you understand that, Sheila? Portia, do you get that?
Yeah.
Lauren, are you with me?
Yeah.
That's all I need you to be. They're right there. Eden, do you understand it? Are you there? Not completely. I'm telling you that this equation says 2 particles of that plus 1 particle of that yields 2 particles of that. That's it. That's all I want you to be. Is that okay? Ling Ling? Johnny? Yes? Jung-in, you get it? All right, if we're talking about particles, can I say 2 dozen plus 1 dozen equals 2 dozen? Can I say that? I can't. If it's 2 to 1 to 2, can it be 24 to 12 to 24? Can it be? Can it be 2,000 to 1,000 to 2,000? Why not? Don't look at me like it's weird. You're looking at me because it can't be that simple. That's what you're saying to yourself. Wait a second.
I understand how to balance out the things, but you have to put the atoms in there. Otherwise, you can't just like put the 24 and 12 out there.
Yes, you can. Why not? If you cut up all 4 hydrogens, right? All 4 hydrogens, you're going to end up with 8,000 of them, right?
Okay.
Okay. And you're going to end up with 2, and then that'll be 2,000. So how many total are you going to get? Total particles are you going to get? How many total particles are you going to get? If you're going to split this up, you're going to have 4 hydrogens, but you have 2,000 of these particles. You're going to have 8,000, aren't you? Aren't you total hydrogens?
Yeah.
Yes or no?
Yes.
Okay. How many total oxygens are you going to have here?
2,000.
You're going to have 2,000. Okay, good. How many total particles of hydrogen and oxygen are you going to have here? Total particles. Well, you have 3, right? You have 3, but then you have 6, right? What's 6 times 2,000?
12,000.
Did I do something wrong? 4 is 8. This will be 3, 6. 6 times 2.
Is 12.
12. Is that right? What did I do wrong? This is 2. This is 4 of them, right? This is 2,002. Okay, good. So if I have 2,000 particles times 4, I have 8,000, right? Yes? If I have two atoms of oxygen times 1,000 particles, how many oxygen atoms does that give me? Right? So I'm going to mix 8,000 hydrogen with that many oxygen, right?
Oh,
Correct?
you counted oxygen on the right side as 2,000 instead of 1,000. It's only 5,000 times 2. Plus 2H is 4,000 plus 1,010 is 1,000.
Say, I can't hear you, Johnny.
He's saying that
For
it's
2,
2,000.
the H2, that's only 4,000 plus O, that's 1,000, so that's 5,000 times 2 is 10,000.
You get it? So this is going to be, what, 10,000, right?
Yeah.
You get that? Not 12,000.
Yeah.
Okay? This will be 10,000. You get it? So that's the total number of particles.
I understand they're balancing equation.
And no, I'm not just balancing an equation. Yes, I'm balancing an equation, but it's what's on the right is on the left. It's all it says. And this is a static example. In other words, I'm not talking about kinetic energy. I'm not talking about kinetic theory. I'm not talking about anything like that. I'm just simply saying I have X number of hydrogens here and oxygens here, and I have X number of hydrogens and oxygens here, and they've got to be equal. That's it. And that's it. I'm not saying how they're going to combine. I'm going to say that they can combine, and they're going to combine in that fashion. That's all I'm saying. I'm not saying anything more than that. Is that okay so far? Lauren, are you okay? You better, or I didn't answer your question, or what?
It's fine. Like I said, I already knew how to balance equations.
So you did learn something in middle school?
Yeah.
Okay. So what happens if I said, could I say that this is 2 moles?
2 moles of water?
2 moles.
Okay, but 2 moles of hydrogen or 2 moles of water?
2 moles of H2.
Okay.
2 moles of that particle. Can I say that?
Yeah.
Then how many moles of this particle would there be?
2 moles?
No, there'd be half that. There's half the number of particles. Isn't there? According to the balanced equation, there's half the number of particles here. So there's only 1 mole. Then how many moles are here?
3 moles?
No, it's right staring you right in the face. It's only 2 moles. Now I thought you said you understood how to balance equations. Okay, but balancing an equation is not just making an equal number of atoms on each side. It's understanding that the balanced equation is actually a ratio of combination of particles. That's the big thing. So when they combine in this ratio. So when you balance an equation, Lauren, you balance it according to the lowest ratio. Is this balanced? Yes, this is balanced. That's balanced, correct? But is it balanced correctly? No, because it's the lowest ratio. How are we doing so far? Are we okay? Now, what's the mass of 2 moles of hydrogen? Now be careful before you answer. Think.
Wait, is
Measure twice, cut once.
it, is it that specific amount of hydrogen, or is it just a regular?
What I said to you is this. Particle, atom, ion, molecule, right?
Okay,
What is the mass in grams of 2 moles of that particle?
4.
What did you say?
4 grams.
Who said that? Chile? Could you see me after class, please? You're absolutely correct. Yeah. You're absolutely correct. 4 grams. Is that okay? What's the mass of 1 mole of that particle?
32.
32 grams. Is that what you said, Portia? You all kind of said it together. Who's going to buy the Cokes? Okay? And so, how many moles of this is it going to be?
20. Wait, no, sorry.
36, 40, 4.
They're thinking. It's really quite cool. I like this.
Oh, yeah, so 36 grams.
4.
Yeah, 36 grams. Wait, is it times?
Wait, no, yeah, no, it's like 36.
What's the mass of 1 mole of water? We just did it over there, remember? It was like right here.
18.
18 grams, right? What's 2 times 18?
36.
How'd you get 34?
Sorry, I forgot that there were, I forgot to like multiply the 2 and the hydrogen too.
Common mistake. Common. It's okay. Another proof that it's balanced. What's 4 plus 32?
36.
The mass on the left equals the mass on the right. You get that? Now this is stoichiometry. Okay, and then I'm going to write the definition on the board. Okay? Yes? Do you understand that if I have 2 grams of that, how many grams of this am I going to have? 1?
16.
16 grams. And how much of this am I going to get?
18 grams.
18 grams. If I have 1 mole of this, 1 gram of this, how many grams of this am I going to need?
8? 8 grams.
And how much of this, Johnny? Johnny, how much of this?
9.
9 grams. Right? How about if I have 8 grams of this? How much of this am I going to need? What is it? Eden? Did you say 64? Okay. And how much of this am I going to get? Right? You okay with that? Yes or no? Yes or no?
Yes.
So what are we doing? What are we doing? Do you understand that these are proportional? Do you understand that there are embedded in a complete balanced formula equation, otherwise known as a stoichiometric equation? This is a stoichiometric equation. A stoichiometric equation is a complete balanced formula equation. Write that down. A stoichiometric equation is a completely balanced formula, chemical formula equation. That's what a stoichiometric equation is. Keep writing. Stoichiometry is the study of the inherent constant ratios within a stoichiometric equation and the comparison of those constant ratios that are proportional to one another and constant. Did you get it? That's the whole chapter. I gave you literally a third of the chapter. So for instance, let's say we don't know this mass. We don't know that mass. That's x. How are we going to find x using proportional relationships? What do we have to compare? So we're going to compare hydrogen, a known, with an oxygen, an unknown. Yes? Do you understand that? Okay. So we're going to say 2 hydrogen compared with 1 oxygen. Is that okay? What's the constant ratio that's built into the stoichiometric equation that we discovered in like the first or second step of this process, depending on when you start counting steps? Isn't it going to be 4 to 32? Don't we know that? We did that. So hydrogen to oxygen is 4 to 32. 4 to 32 is, right? 4 to 32. 2 is to what? So 4 is to 32 as 2 is to what? This is a constant ratio. This is a constant proportion. So what's 2 times 32 divided by 4? 16. Well, we know that's true. But that's almost 7th grade math, maybe even earlier, right? So can't we, what happens if we say this? What happens if we say this? 43 grams of this. How much of each of those? Now, it's not so easy, is it? It's not so easy. 2 problems. Are you ready? So we're going to compare hydrogen with oxygen and then hydrogen with water. Chile.
Can we just do the cross multiplication? So we're doing the cross multiplication to find the mass of oxygen, and then can we just plus it together to find the mass of water molecule?
Absolutely. Yes, I don't want to do it that way, but the answer to your question is yes, of course. Absolutely. I'll tell you what Chile said in a second. So 2 is the hydrogen, as 4 is to, what am I doing? As oxygen, as 4 is to 32, equals 43 over x. Are you okay with that? Okay. And then it's going to be 2H2 over 2H2O equals 4 over 36 equals 43 over y. So do those calculations. What do we got? What's 32 times 43 divided by 4?
344.
Jeeling, go ahead.
344.
344? And what's 36 times 43 divided by 4? I want to discover essentially what you said, Jeeling.
387.
387, right? Correct? So what's 43 plus 344? 387. So Cheeling's question is, well, why can't you just add these two and you're going to come up with this? Of course, absolutely. But I simply wanted to show that concept of the proportional relationships that I gave you relative to the definition of stoichiometry is true. It's true. The only reason I spread that out a little bit, Cheeling, is because what happens, you get this? Can you follow me? You can do some problems later on. It's not hard. Yes? It's all it is. They'll become longer, maybe more complicated, but it's just these steps. So what are the steps that I do? What are Mr. Darcy's steps? They are, you write the complete balance formula equation, you put in the stoichiometric masses above, and you go to work. It's easy. Foolproof. Foolproof. Okay? You get it? Yes or no? Okay, good. So, what happens though when you get something like this? And we're going to do this reaction next week. What happens if you get this? Lead nitrate lead 2 nitrate plus sodium iodide equals, anybody can guess what those two will combine to? Anybody? I know, I got to teach equation writing as well. It's a really hard chapter. It's going to be lead iodide plus sodium nitrate. Is that all on the screen? Is it? Okay. How do you balance this? I'm going to give you a hint. Don't balance the atoms. If you have a polyatomic ion on the left and you have the same polyatomic ion on the right, balance polyatomic ions. Don't balance the atoms that they're made of. Yes?
You put 2, like, before the sodium, not, yeah, and also the,
That's right. Easy. Easy peasy. Isn't that easy? People would like go crazy with the atoms. Okay, so now that's a little bit more complicated. Now the first thing you're going to do is put in the stoichiometric masses. Shall I be your periodic table? May I be your periodic table? I have a tie on. I look nice. Yes. Okay. So lead is 207.
Memorize the masses of all these?
It's just years of doing this, girl. Just years. Nitrogen is 14. Oxygen is 16. Sodium is 23. Okay, so what's the mass of sodium nitrate? So do this for me. Get it? You got a calculator? I'm going to be a interactive periodic table. Okay, I'm going to be an interactive stoichiometric machine. Okay, 207 plus.
Wait, what's iodine?
Was iron?
Iodine.
Oh, iodine is. I don't remember. What's iodine?
126.
Yeah, 126. That's right. I remember.
127.
127. Right. All right, so 207 plus, well, let's do the nitrate first, right? So 14 plus 48 is what? 62 times 2, 124 plus 207, 331? Yeah, I know, I remember that. It's just, I've been doing this for too many years.
Times 2.
No, there's no 2 there.
No, there's 2.
No, I did that 2 already.
Okay.
I did this plus this, 62, times 2, 124, plus 207, 331.
Okay.
What is 127 plus 23? 150 times 2? What is 127 times 2? 254? 254 plus 207?
461.
And then 23 and 62? 23 and 62
85.
85.
times 2?
170.
What is 331 plus 300?
631.
What is 461 plus 170?
630.
Don't add it, really add it. Is that right? So you did something right. You're probably right. Okay? Now it becomes a little bit scary. Because first of all, when you make up solutions, you're using small masses. So let's say 2 grams of this. Right? Now, if you have 2 grams of that, I want you to do this for homework. I really want you to do this for homework. And we're going to put this on the board. Actually, you know what? What do you have next period?
3 periods.
All right, if you want to stay, stay, and I'll complete the video. And I'll complete the video as Stoichiometry Part 2. And I'll complete the video. Okay? And,
Where
okay?
did part one go?
This is part one. What's wrong with it?
It's a little notification just popped up.
All right, let me read the notification, but we're off part one. Hopefully the video took, because that was a good video. Low battery. We're still good. We're cooking. All right. Part one over.